Hello there, I am Shane, and today I'll be presenting on behalf of my group P1 Group 7. I will go through a brief overview of our knowledge structure, the Smalltalk function, how it resets memory, and how it saves and loads files. The structure my team decided to use is three linked lists, one for each intent, where an array of three addresses would hold the head of each linked list. The intent consists of what, who, and where. The entity is everything after the intent, less the is and are, and the response is for the answer for the question. As for the creation of node for the linked list, the program will malloc a size of the structure in memory and copy over the content of each of the variable into the structure. The program will then set the next node of the newly created node to the current head of the list, and then set the newly created node as the head of the list. Now I'll begin to talk about the Smalltalk function of the project. First, if the user keys in the word good, the program will reply with good day. But if the user keys in the word good with anything afterwards, the program will reply with good blank to you too. Next is the its function. When the first word the user keys in is its, the program will reply with indeed it is. So it's hot today will reply with indeed it is. And for the hey, hi, and hello function, we implemented it to print out a random reply within an array of 5 choices. So if we spam it, we could probably get in different answers. You can see the different variations. If the start of the sentence is not any of our predefined words or intent, the program will not recognize it. An example is that. So that's hot. The program will not recognize it. Or even how are you doing? The program will not recognize the word how. Next is the empty response or conversation. When the user enters in an empty response or conversation, the program will reply with a sad face. An example is right here. You could just press enter and Prometheus give us a sad face. Or let's say, what is today? It prompted us for a response, and if you leave it empty, you'll give us a sad face and we can ask it another question. Next is the three predefined intent, which is the what, where, and who type of question. I can show a demonstration right now. What is SIT is these, and the bot prompted me for a response. Singapore Institute of Technology, and it's saved to the linked list. Next is where is SIT for ICT, and we can reply with NYP, and who is the best professor, and of course we know who that is, Frank Guan. Well, now we can test if this works. So it should be saved. We can ask what is SIT, and it replies with the answer of our response. Same for where is SIT for ICT, and it replies with NLP, and best, who is the best professor, Frank 1. There we go. Now how this program works. You'll iterate through the linked list with the same intent. If it is able to find a matching entity, it will check if there is a response. If the response is null, or if it is not able to find the entity, the program will prompt the user to enter in a response to be saved into its knowledge. Alright, now for resetting memory. The program will iterate through the array of headers for the linked list setting the current node as temp and the next node as the head, freeing the temp until the head equals to null. I can demonstrate that it works with this program. We currently have a few inputs. Key reset. The chatbot has been reset, and now we can ask the same question, such as what is SIT, and it prompts us to input the answer again. Can enter in space to ask it another question, such as where is SIT for SIT for ICT, and it doesn't know. And who is the best professor? And it doesn't know that either, so it works. Now for saving. The program will iterate through the array of headers for the linked list, saving out the content in pairs of entity equals to the response into a config file that could be accessed later to do loading. We could do a quick example. We could do what is cat, not dog. Where is cat? Not here. And who is cat? Not to you. Now we can save this file. Save as cat.ini. And it has been saved to a file, a cat.ini within the repository. Alright, this is the repository for the project. As you can see, cat.ini has been saved, and we can edit Notepad to see its content. As you can see, the content has been saved out. Lastly is the load function. The program will read the file, and it will tokenize each line using the equal sign, and before appending it to the current knowledge, it will check against existing knowledge. If there is a matching intent and entity, the file's content will overwrite the content in memory. And we can show an example of that right here. We could reset the current knowledge, ask what is cat, and we'll answer it's a cat. Then we will load cat.ini, and it read 3 responses and asked the same question, what is cat? And it responded with the one that was in the ini file. And that marks the end of our presentation. Thank you for watching.